So I'm going to put a note here that I want you to get down. It's just one method. So what is substitution according to this lesson? It's just a method to find the exact solution to a system of equations. Does anyone remember what a system of equations is? So what is a system of equations? Like, how do you put it in your own words? Or
it's like two different equations that either have 1, 0, or infinitely many solutions.
Good, very good. It's basically a grouping of equations, and we use that symbol, the open brace, to show that these two equations are a system of equations. And yes, they will either have one solution, no solution, or infinitely many. Those are your options. Good. So we already looked at one method of solving. It's graphing. I'm going to give you a tough graph in the future where you have to graph the lines, and if you're not careful, you will not get that answer. Like, it will not be very clear. But you can get it if you're careful. You're going to look at some of these problems, and we could have graphed them all and get the solutions without using substitution. But man, it is really, really hard. Imagine starting at 1/5 on the y-axis. Okay? That's bad enough. And then your slope is 21 over 3. Or I'm not 21, 21 over 4. Up 21 over 4. Now, there are strategies to help you out with that, but that's hard. If you mess up, all that work for nothing. So we got to get a better system, a better method, and that's substitution. All right, let's look at example 1A. Hope you guys are paying attention so you guys can get these. So if I ask the question, why is this a system of equations, or how do I know it's a system of equations, it has that open brace right there. Now, I know your book doesn't do it, but I'm really not sure why not. I've only seen it that way, and this is telling me these guys go together. All right, if this is a system of equations, do you remember some facts you know about these two equations? Not only will you have possibly one solution, no solution, or infinitely many, but what do you know about the x's and the y's? In this case, x's have to be the
X.
What'd you say?
Oh.
Oh, okay, you're thinking like slope intercept. Okay, you can solve for y. If you want to graph, this is what I'm trying to get. Aren't the x's going to be the same value, and the y should be the same value if we have a solution here? Do you guys remember that?
Yeah.
Okay. If not, you're going to have a no solution or infinitely many. But these x's are standing for the same number. These y's are standing for the same number. So you know what our goal in this problem is? Find what those numbers are. Okay? We could graph it, but we're going to do a different method called substitution. All right. Step 1. I'll write out the step and its instructions in this problem, and then I'll just kind of go through it in the other examples. Isolate. This is where you have some flexibility. Isolate one of the variables in either equation. And I had to pick my words carefully here to try not to confuse you, but I need to explain it to make sure you don't get confused. All right, isolate, that means get it by itself. You got to get one of the variables by itself. Mr. A, which one do you get by yourself? You can pick. But there's an easy one, usually, and there are harder ones, usually. So I'm looking at this and thinking, okay, how many of you see that there's an x variable, a y variable in the first equation, and an x and a y in the second equation? So I have 4 options. 4 options. One of them is easiest, and it's the one that's almost already by itself. Which one would that be? So which one's almost already by itself? The first x. Good, right? You guys okay with that? Good. I would say this guy right here, that's the one I want to isolate. So this is what I'm going to do. I'm going to take that equation, x plus 4y equals 1. So it could be x or y. could be x or y, and it could be the first one or the second one. And I want to solve for x. Can you guys solve for x down there? Which is nice. Again, you can pick any of them, but this one's easy. And you should get x equals 1 minus 4y, or if you wanted to do it differently, you could say x equals negative 4y plus 1. Sorry?
That's a big one.
It's a big one. All right. How many of you got this? How many of you got that? Okay. Pretty easy? Yeah.
So you know with the slope, you typically like to put like the x, you like to put it before the y, or the x to the right.
So like these two?
Yeah, it's the same.
Yeah, you don't have to. You can. Like if you always want to, I just like the format. You could do that. It won't affect your answer. But yeah, I got this right here. So that's your first step. Isolate one of the variables in either equation. All right, which x did we isolate? Because this is important. The first or the second? Okay, the first. Because my second step, so I'm going to go to my second step, is to, and I hope this is where you can see where we got that name, substitution. Substitute the isolated variable, remember the one we just solved for, into the other equation. Substitute the isolated variable into the other equation. Okay. So I don't have it up here, but what am I referring to when I say the other equation? What's the other equation in that system of equations? Which one's the one I didn't use yet? Anybody? The 2x minus 3y equals negative 9. Is that the one I haven't used? All right, that's the other equation. So now I'm going to write that down so I can reference it, and then I'll show you what I'm doing with that. Okay, do I know what x and y are? I still don't know what they are, but in a sense I actually do know what one of them is. Okay, do you remember that other step? Remember how I solved for x? What did x equal in that other step 1?
Negative 4y.
Sorry, 1 minus 4y? Is that 1 minus 4y? Okay, x equals 1 minus 4y. Do you guys agree with me? 1 minus 4y from the first step. Do I know what that x equals? 1 minus 4y. So I'm going to substitute. Instead of x, I'm going to put 1 minus 4y. Isn't that what I said in the first equation? So technically that's it. And I'll review this in just a moment. Go ahead, Walker. Yeah.
Why can't we do negative 4y? Because that's what you always say to do on negative.
I think Benton asked that question about, like, how do you write negative 4y plus 1? Is that what you're saying? You could do that. It's going to come out the same answer.
Okay.
So you do that, I'll do it this way. We'll come out the same thing.
Is one easier?
Is this easier?
Which one's easier?
I would say this one's easier, but some of you are like, you have a certain format you like, just you're okay to use it. Yep, that's okay. That's why there's so much flexibility. And even my instructions, I was trying to think, how am I going to say it without telling them there's only one way to do it, and I have to be vague, like I have to be general in how I describe it, because now you're using your creativity here. Okay, the reason I did this, the whole point of substitution, is that look at this equation right here. Remember, this is the second equation. Instead of x, what did I put?
You put 1 minus 4y.
And isn't that what x equals, according to my first step? So I substituted x for 1 minus 4y. Okay, and it's right here. Now, in this equation, how many variables do I have? How many variables do I technically have? 1, right? I solve for y on this one. Go ahead and solve for y, and if you need help, I'll help you. So you're going to do distributive property. You got to be super careful. 2 times 1, 2. 2 times negative 4y, negative 8y, and then you still have that minus 3y equals negative 9. Go ahead and isolate or solve for y, and let's see what you get. It should be, in this case, it'll be an integer, but don't be afraid if it's not, because it happens. Okay, so I'm going to keep working up here. So I combined these two like terms. I got negative 11y. Then I'm going to subtract 2 from both sides. And then I get negative 11y. Oh, yes, equals negative 9, so negative 11. And then I divide both sides by negative 11. And I finally get my y equals what? Y equals 1. So I'm going to circle that right here. So I found what y equals. Exactly, right? I'm not like down. Y equals 1. That's the second step. You just found one of the variables. And again, you could have found the x or the y first. It just depends on what was easiest to do. So I got my y. That's my second step. You guys okay so far? Like at least following me? And then we'll do some on our own to see how you do. I'm going to go to the third step. Step 3. Substitute. That's why we call it substitution. Substitute known, and this is where I had to explain my words. Known variable into, and this is the cool part, any equation. And when I say any equation, I don't mean like, oh, you make up an equation. No, any equation that's already been up here. Into any equation to solve for unknown variable. Okay, variable technically means unknown, so that's why I have to clarify this. What am I referring to with known variable? Which one do I know? Y. I know y. Y equals 1. Which one's the unknown variable? X. I still don't know that. Okay, do I know what y equals? Yes, it equals 1. I want to find x. Now I can pick any one of those equations, and usually I pick one of the original two. Do you guys remember that x plus 4y equals 1 and 2x minus 3y equals negative 9? You pick which one you want to use and go with it. So which one do you want to use? Which one looks easiest? I think it's the first one, I think, right? So watch what I'm doing. I'm using this equation. I'm going to use that first one, the original first one. Do I already know what y equals? Yes. So I'm going to substitute y with 1. You see that? Why would I do that? Because what am I solving for now? The x. X plus 4 equals 1. Subtract 4 from both sides. Oops. X equals negative 3. Okay? That's the point. That's what you... Yeah. All right. Here's my final answer. It's got to be an ordered pair, and it's got to be the x and the y. So what's my x? Negative 3. What's my y? 1. This is my answer. I want to say this. This problem would have been easier to graph and then solve. Would have been easier. But it is another method to use. So we're going to do it again. We'll go through the whole process again. It is another method to use. And on this next problem, graphing is not nice. And then on the third problem we'll do together, graphing is not nice. I hope you'll be able to tell. I'm glad we didn't have to graph that. So I'm going to get to a point where on the test I'm going to say, use a method to solve for the system of equations. You can pick whichever one you want, as long as you find out the right one. Okay, questions so far, and then we'll go through another example, because it is tough. It's not easy. Yes, sir.
So, I was looking on
Equation? Because I just wanted, it seemed the easiest to me, but I could have used the other one and then solved. Did anyone use the other one? Okay, if you were to use the second equation, you still get negative 3 if you did it right. That's the cool part. Okay, that's all right. That's good. Maybe you just got to look through it again. Yeah. All right, number 10 on page 466. If you can go there, 466. This one's slightly easier, as in it's not as complicated stepwise, but we'll go through the 3 steps again. So number 10, go ahead and write that problem down. Y equals 3x, and then x plus 2y equals negative 21. By the way, your y-intercept would be negative 21 over 2, which is negative 10 and a half. And then your slope would be 1/2. Negative.
Yeah.
It's not, I mean, it's not impossible, but man, that's not easy to graph. So there's got to be a better method, and it's substitution. All right, first step, so I'm just going to write the number. Solve for one variable in either equation. And you know what they did for you here? Wait. Oh, they gave it to me. You see it right here? So I'm going to solve for the first y. It's already solved for. I'm using y equals 3x. That's great. They already got it for me. You could have also solved for, what's the second easiest? Well, what do you think you could have solved for if that wasn't already solved for? Yeah, the second x. Could have done that. All right. Anyway, but that one's easy. It's right there. So, step 2. I'm going to substitute y in the other equation, which is which one here? What's the other equation? Second one. And instead of y, what should I put? 3x. So instead of x plus 2y, I'm going to put x plus 2 times 3x equals negative 21. So do I know what y equals? Yes and no. I don't know the full number, but I do know that y equals 3x. All right, can I solve for x on the second one? All right, go ahead and do that. So you're going to do x plus, multiply these two, you get 6x equals negative 21. Add these two together, you get 7x equals negative 21. Divide both sides by 7. And what is x going to equal on this one? Negative 3. Okay, so I got x. And I can actually, I'm actually going to fit all the steps on this one thing here. So I already know what one of my answers is. We said x was negative 3. That's my first answer. And don't forget, put it in the right spot. If you switch the two numbers, that's a totally different point, and it's incorrect. All right, step 3. I know what x is, so I can put x into here. This is the cool part. Here or here. Which one do you want to put it into? Sorry, this one right here? This one's the easiest one to do. You can do it on this one, but I'll put it in here. So y equals 3 times, what does x equal?
X equals
So what does y equal now? Negative 9. That's your answer. That's where the two intersect, at negative 3, negative 9. You see how that worked?
Yeah, I see.
So, could you have graphed this? Of course you could have. It's a little tougher to do. So, remember how I talked about this one being hard to graph? And that's just one of them. Then I have to graph that one. If I mess up on either one of them, my answer is going to come off. It's going to give me a false answer, and all that graphing didn't do it. Let's do another one, number 14 on that same page. Let's see if you guys can do a little bit more on your own, bless you. And I'll help you out if you still need some help, so that's okay. Can anyone tell me why we call this method substitution? Yeah, we substitute at least twice. We're just putting in a value for a variable, vice versa. I'd say there's if these 4 variables were going for the easiest one to solve for, there's 2 of them that are very close, but one of them that's just slightly easier. Which one do you think is the easiest to solve for? How many of you think it's one of the x's?
The bottom one.
Okay, which y then?
The second one.
Yeah, I'm going to go with the second one because it's a positive. I mean, you could solve for that first y, but you're going to have to divide or multiply by 1. I think the second y is good. So solve for that second y. So all you had to do is add 3x to both sides. you would have gotten y equals negative 9 plus 3x, or 3x minus 9. There you go. Or plus negative 9. Either way works. So you got your first step. Second step I'll write up here. Second step right here. I use the second equation, right? So which one should I use next? The first. So instead of y right here, what am I going to put in there?
You're going to put in negative 9 plus 3x.
There you go. Be super careful on this next step, and I'll try to make it as clear as I can. So instead of y, we said 2x is still there, minus negative 9 plus 3x equals negative 4. So do you guys understand? This equation is exactly the same as what they gave me. What's the only thing I changed? What y is. So you see how it's negative y? Negative y. You got to be super careful with those signs. That's why I put parentheses on my substituted values. All right, so let's go through this very, very carefully. 2x. What happens with this negative sign and these two things in there? What's the basic change from what's in the parentheses and then what comes out of it?
Turn opposite.
Yeah, so really there's a negative 1 right here. So what's negative 1 times negative 9? Positive 9. And what's negative 1 times positive 3x? Negative 3x. So that's all that happened. The signs change. All right? And then add like terms, solve for y. So I'm adding like terms here. And then I'm solve for x in this case. Negative x, negative 13. Yay, I got negative 13. Whoa. What did I add wrong? Dude, is negative 13x?
No.
What's wrong? Are my eyes playing tricks on me here? Yeah, negative x equals negative 13, but what does x equal? 13. All right, so I have my x. I'm going to have to move to my next screen. So I have here x equals 13. All right, third step, I'm going to substitute x into either one of these equations. So I'll go back. Which one do I want to plug it into?
First one, yeah.
Okay, can I give you a little hint? There's a third equation I could plug it into.
What are you?
Taylor?
That one.
Tell me when to stop.
There.
This one. Do you remember how this one is the rewritten version of the second one? Do you guys see that? These two are the same, just rewritten. I would put it in here because it would automatically, when I do all this little work right here, I'll get y automatically. But you could do either one of those as well. Can we do this? I don't know if you've already done it. Can we try this out? Can some of you put 13 into this first one? Who can do that for me? Yeah, good. You three? Can some of you put 13 into this one? Got one. Anyone else? Don't be shy. Okay. And then can some of you put 13 into this one? Okay, one. Anybody? Can some of you are like, I don't want to put 13 in. You got to pick one. So put whichever one. Okay, go ahead and do it. Go ahead and put it in. See what you get. Some of you will put 13 into this x, into that x, or into that x. And then solve for y, whatever it takes to solve for y. And if you did it correctly, you should get this number. All of us should get the same number. I'll tell you in just a minute. Which one did you put in?
You got it right. I can't get it right.
Try plug it into like this one.
Yeah,
Right here. So instead of x, you're going to put in 13. Yeah, do the order pair. Put 13 and solve for y.
Katie got it right.
I think I got it.
Oh.
Yeah, that's what Katie got. Yeah, me.
Let me ask it. Sorry? For what? Okay. Okay, got it. Yeah. Let me check you without making Swivl come to you. Got it. Got it. Got it. Got it. Got it. Good, good. And we did not all do the same thing, which is, again, that creativity. Mr. A, I really like that first one. No, I like that second one. No, the third one's best. Whatever. Do it. Yep, good. Sorry, didn't check. Yep. Do you have it? Not yet? It's okay. All right, how many of you got? What'd you get when you solved for y up here? Whoever did it. Just say it out loud.
30.
You got 30 for y, right? What'd you get for y on the second one? If you solved 30. What'd you get for y on the second one, or the third one? 30. So your answer should be 13 and 30. It doesn't matter which one you use for the last step. Do you guys understand that? Does that make sense? Because remember, well, let's see if you guys can get this. Let's see, right? Why does it not matter which equation you plug in the x for in this case? Why does it not matter?
Because
they're related.
Okay, they are related, and
Both are the same.
all these y's are the same, and all these x's are the same. So you just plug it in and solve for it. That's it. All right, one last example. It's actually going back to example 1b. Example 1b. Sometimes, though, guys, strange things happen.
Wait, what do you mean?
Not stranger, strange. All right, let's look at example 1b. We went 1a, and then we went to some other ones here. Excuse me? I did, yeah.
No, this is bad.
wait, you do?
I did, yes. Yeah, what got me was it's like from the 80s, so that hooked me in. Okay, but anyway, okay, we're done with that. We can talk about that later. All right, this one's a little bit tougher because you're probably thinking, oh no, the fraction. Go through the same process. Which one of these variables is easiest to solve for? First step, easiest. I would say the first y here or the second y. I would say either one, but this one is because I don't have to do much. I'm going to have to do one step to solve for y up here. This one would take 2. So either one would work, but let's solve for that one. So step 1, solve for that y. You're really going to get y equals, if you subtract 5/2 x from both sides, you should get y equals 4 minus 5/2 x. Oh, man. Okay, but you solve for y. That's what you wanted to do. And realize the second equation, if you solve for y, you're also going to get a fractional x. But that's okay. We'll deal with it. All right. If I solved the first equation, where should I plug in this? The second equation. All right, so I'm going to do that. 5x plus 2 times what?
4 minus 5.
Yeah, 5/2 x equals 8. All right, that could be a little bit tough. So we'll work it out if you need help.
What?
Yeah. All right, do you see how I solved for the first one? The first y? Yeah, it's like, what do I do here? Okay, let's take it one step at a time. 5x is 5x. So I'll write that up here. Okay, what's 2 times 4? Positive 8. What's 2 times negative 5/2 x? What happens with those 2's?
Negative 5.
Yeah, you get negative 5x. Negative 5x. So these two right here.
Wait, not Mr. A. That's not what happened.
So hold off on that. I see you guys got ahead. But how many of you got 2 times negative 5/2 x? Or yeah, 2 times negative 5/2 x equals negative 5x. You good with that?
Yes.
And that equals 8. These two combined together, they cancel each other out because they're on the same side. You just combine them, and you're left with 8.
Equals 8.
Wait,
Or 0 is 0.
True.
All right, is that true or false?
That's true.
True. That's a good thing.
Is it all solutions?
Not all
Or
solutions.
Infinitely. Oh my! I knew this guy come. Oh my gosh.
That's infinitely many.
Negative 40 million ones.
Oh, sorry.
No.
And this is, I actually thought of this, how to explain it to you guys. Infinitely many doesn't mean any solution. but that there's infinitely many ordered pairs, ordered pairs that would fit. So if you found an ordered pair that fits this first one, it would also fit the second one. And there are an infinite number of those, but that doesn't mean that anything fits. You kind of see what that's
I
saying?
understand why, because if you divide everything by 2, it would be.
Yeah, do you guys notice the difference between these two? If I divide this by 2, that by 2, and that by 2, it is that equation. Now, listen to me carefully because there's another situation. Remember, how many types of solutions can we have? We can have one solution, infinitely many, or no solution. Okay, this is how you know it's going to be no solution. You work the same problem out, for example, and you work it and you get 8 equals 7. Or something that's false. Do you know what that means? There are no solutions. They're parallel lines. And you can check the slopes and you'll see that they're the same. That's what's awesome about this. So how many methods do we have to solve systems of equations now? 2 so far. Graph them, yesterday's lesson, and then substitution, the second lesson. Okay, I think you guys did very well. But let's go with 17 to 33 odd. Oh my. This is the fun part. Oh. And 46 to 51. No, you don't use graph paper. Use your regular line paper because you don't have to graph them. Actually, what's his name? Unfortunately, the man who. Sorry.